hard drive here. It's much faster. Okay, I'm recording now. So Chris, your microphone should be on. I'm going to mute, so go right ahead.
Hi, everybody. My name is Christopher Almoila, and I'm doing the unit assembly drawing and fab ticket presentation. We're going to start off with a quote from someone we all know and admire. This quote is the foundation of all the work that we do at this stage. Just Get It Right by Joe Mitchum. Simple and to the point. Here's some recommended videos that you should watch before, or if you did attend the previous engineering presentations, starting from prototype units and setup, metal takeoff, and then metal takeoff checking. The goal of the stage during fabrication is finalize the documents needed by the shop to fabricate and assemble units. The main documents are the unit assembly drawings and fabrication tickets. The order of the process is the following. Starts with the pallet schedule from Seoul and Quentin, and then the prototype units from Pedro and Joe. Material takeoffs from Yana and Margie, and then fabrication tickets before release to the shop. The timeline is the fabrication drawings start at an average of about 2 to 3 months after material takeoff, and the schedule varies depending on how many weekly releases are required for the project. If anybody has any questions, just put it up on group on the chat. I'll try to answer it if I see any. So what do we look for before starting a project? First thing we do is set up the handoff meeting. This involves the prototype group, metal takeoff, and the project coordinator. Afterwards, we will meet with the PM, the drafter, and again, the project coordinator. We would ask at this stage if the Revit model is in BIM 360, if this was not already mentioned during the handoff meeting. If it is a BIM 360 model, we would have to fill out a request form to gain access to the Revit project. Next, I would check for completed pallet schedule and also check if all the material takeoffs have been completed. And then review the pre-takeoff meeting notes, mainly looking for die status, shop drawing status, engineering calcs have been completed, distribution information for field use items, and vendor supplied parts such as window washer tiebacks. And also ask for the Trello board link. And then I would check for the completed miscellaneous fabrication drawings, which consist of the shop use steel, shop use brake shapes, and any post-painted fabrication drawings. Afterwards, I'll also look for the glass takeoff units for reference. And lastly, I would get a current set of, or ask for the current set of PDF shop drawings. Look if the CAD drawing exports exist and if they are the same date as the PDF set. If they don't exist, then I'll ask the drafter for the exports. We'll also look for any performance mockups created on the project and also review the prototype units that Pedro created. So before we start the project, there's like a couple of documents and procedures that we have to follow. One of the documents that I usually create in the beginning is the unit tracker spreadsheet. The upper half is for scheduling, and the bottom half is more for the project engineers to see how many units, which units they need to work on. I make this spreadsheet. It's a current unit to glass unit comparison by location ID. As part of the process is to reset the unit numbers in the Revit model to get any changes after glass takeoff. If any of the families changed, if the elevation changed, then the unit would also change, and we want to see the differences. And create the updated key sheet onto the Bluebeam Studio session. Let's see. Oh, this video is just describes how to, once we get access to the Revit model, to reset, sync, and upload the palette schedule to the portal. So one of the things that we want to do first is reset the unit numbers so we can update the database with the newest information from Revit. So what I'm trying to show over here is after you UPD, you sync the model, but this model is detached, so it's not available. This is a unit assembly drawing. The description shows the metal material information, miscellaneous material, the dimensions, the different types of dimensions, overall dimension, the daylight dimensions, and mullion widths with sometimes from dimension point to daylight opening. We have our infill mark numbers, glass, and louvers or backpans. Our detail bubbles, gasket callouts, metal mark numbers, and assembly notes. Project name on the bottom and the unit number. What is this video? After the takeoff database is updated, we can then start creating a unit drawing. Using the data and fabs created during prototypes in conjunction with the data added during metal takeoff, we can see what type of data, what type of information we need to add or remove. To make sure it follows the current set of shop drawings. So I'll run UPD on this unit drawing. We can see that there are a couple of misplaced items in space. Part of the stage is to verify if all the parts verify if the correct parts are in the correct location with the correct length. Unlike the metal takeoff stage, this stage has to be accurate, but we build from the information that they have provided. As mentioned earlier, there is a span of 2 to 3 months after material takeoff, and in that span, the shop drawings might have had some updates in terms of material or logic. Um, this is a picture of the fabrication ticket. Describes the different areas. Up on the top left is the fabrication, like part numbers and the location and the side. These are the parts fabrication specific callouts with the miscellaneous material callouts. And down in the title block is the part number description, job name, mark number, part length, details, part finish, and fabrication template. These pictures are represented by these, the text here is represented by these pictures. And then this video shows how to check the unit drawing. So here in the lower right is the cleaned up version of that unit drawing that we created earlier. You just don't have the time to finish cleaning it up. Here in paper space it shows the assembly notes, and in model space we can see that the parts are in the correct location. We can verify that by looking at the shop drawings. This is elevation 215, 215, and what we really want to check is the vertical with the sunshade brackets. So in this view, you can see that the sunshade bracket is attached to the male vertical, and the W75 5646 is attached to the female vertical. We have our channel, pocket filler thing here. And on the other side, we have the male vertical with another sunshade bracket. So quickly, we can just quickly look through the model and see where the parts are. You can look at the horizontal and the location of the sunshade bracket relative to the horizontal. You can see that it is 1 in 1/8 from bottom of horizontal to bottom of the plate. Can quickly measure that, and yes, it is out minus 1 in 1/8. Once we have that, we can now check our fab tickets. And this is the fab ticket that was created from the BIM model. Here we can check the heights, the part numbers, and the notes and any gaskets required. Gives us the cut length, the detail where it occurs, the finish, the fab template, and the mark number. One of the other things that we also have to check is the glass mark number to make sure that it matches the glass takeoff. So I'll pull up the unit number and glass mark number spreadsheet, and then I'll open the glass unit just to make sure the glass is still the same. So the bottom light is the same, the top is different. So L1 is a louver, and the glass bites on the louver is typically 0. But in the model it's something else. Probably wanted to make it look like it won't fall off the opening. And we'll just match the bites from the glass takeoff and see if it still fits in the frame. So now the mark number matches. That is typical of louver takeoffs. It's just daylight size. We can see the glass bites. We can see it visually in model space, and we can see where parts start and stop. This next video is from a class that Zach made about a year and a half ago. Explains more about fab templates. Whoops.
Jobs. Let me go to my jobs. Move on. All right, so fab templates. So all the stuff that we've done so far is mostly to get the metal takeoff. And at least here in Fremont, usually our metal takeoffs happen a number of weeks before we even start doing fabs. So we can order the metal because the lead time on metal's pretty long. So what we're going to be doing now we're trying to get the fab tickets, which are the drawings that tell the shop exactly what to make and how to make it. So we're going to start with fab templates. So fab templates are sort of the base drawing for a fabrication ticket, and it contains all the graphics that you would see on a fab ticket, or most of the graphics, I should say. They're named by the fab number column in the UD window. So if you look over here, let me hit refresh real quick. This column right here, fab, is the fab number, and whatever it says here is determines which template it's going to use when it draws the ticket for these parts. It ignores everything that's in parentheses like this. So the fab number of this one here is just fab 1. The fab template contains all the graphics, like I said earlier. It's got all the notches with their notes, feats, which are short for features, like gaskets and other miscellaneous notes. And they can have attached parts on them, which we'll go over tomorrow, or depending on how this lesson goes, it might be 2 days from now. So to open up a fab template, when you're in the BIM model, it's pretty easy. You can right-click on any of these parts in the list. So let's just pick a horizontal. I right-click on it, and I can say Open Fab Template. And that opens up the fab template for that part. The fab template has, like I said, it just has the graphics. It doesn't have any of the information in it. So it doesn't have the mark number, doesn't have the part number written here. All this stuff in the chart here gets filled out when you make the fab ticket. And you can also preview fab tickets as well, similar to how you right-click open the fab template. You can preview the fab ticket, so you can see what the fab ticket for this part is going to look like. So you can see it has the part number, the cut size, and its quantity. Though when you do a preview fab ticket, the quantity is always 1 because you're just previewing the one part. Many times, especially for horizontals, there might be multiple mark numbers with multiple different lengths, but they all have kind of the same picture using this sort of cut size as a variable. All right, so some of the fab templates, they're generated automatically by the takeoff program. Actually, all of them are. It will look on the server for existing fab templates. So let me show you what that looks like. So if you go to your S drive and you go to fabs, that fabs folder has a list of parts and folders. So when it's looking for a fab template, or you're looking for a fab template manually, you can scroll down to whatever part number you're looking for, say the 2100, like I was looking at. And then these are the built-in fab templates for that part. Your server should have the same fab templates that my server does, so you should have gotten all these fab templates too. So the process that the takeoff program goes through when it's making the BIM model is it will look in your jobs. Let me go to my jobs. So my job right now is in this training folder. This is my backend database. It'll look in fabs dies for a fab template. If that fab template doesn't exist for that specific fab number that you've indicated, it will go on the server and look there. If it can't find that, then it will look back over here and look at the dot, or look for fab number 1. Fab number 1 is special. It's sort of the basis for all fabs. It'll look for fab number 1 here. If it can't find that, then it will go to the server and look for fab number 1. Anything that it finds off the server, it will copy in here, and that's why I have everything, all these other fab templates in here. But all of them are made when you run the BIM model.
So that's just a brief description of fab templates. So when Zach was describing the part numbers in the S drive, those are the fabs that the prototype group has uploaded to the server and created for future use. So the more that they do up front, the more that we can use during final fabs. One thing I forgot to mention was in the fab tickets, there are these notches and notes that we create. These notches are also used later for fabrication. Tony imports it into his process and assigns machining to these. So when he gets this fab template, he'll have these machine programming attached to them. And then before we release to the shop, of course, we have to send it out to checking to our project coordinators, which, you know, is another process where we create everything into PDFs and put it in the checking folder for our project. So in a folder like this. And once it's all final, then we release everything to the shop. I think Ron said he wanted to show the notches for the sunshade brackets. And these are determined by the tags and the notches. So whatever notch we make in the BIM model, it is reflected on the fabrication tickets. And these notches will then get programming assigned to them if they will run this on the machine. I think that's it.
Okay,
That's
so
a lot to process.
open for questions now, Chris.
Yeah.
One of the things that you're showing is how the unit assembly drawings and the creation of the fab tickets works, but there's additional processes associated with actually releasing that to the shop. There's a lot of optimizations of materials.
Mhm.
There's reports that are associated with that. So as you're developing the database, can you just talk a little bit about how all of those things are tied together and how all of that is actually used to generate some of that supplemental information for the shop as well?
Yeah, so let me open up my. So when we before we release to the shop, we have to there's actually a Swiss that we have to follow to make sure that the outputs are consistent to the shop. The first being we upload the palette schedule again up to the portal. You filter for all units and then upload. In case there's any changes that was made afterwards and somebody forgot to upload after they reset the unit numbers in Revit. After we finish checking all the parts and pieces, we filter for the week, and then we optimize.
Chris, are you trying to show us something?
Oh, it's not shared? I'm sorry.
That's okay.
Yeah, sometimes we get drawings as we're doing our process. The drawings aren't matching. We get units maybe that need to be an A and a B because they were bolted units, but they come in as two different numbers. So we'll have to renumber the units. And if we have to do that, we have to upload the pallet schedule again to change, to match what we've done, so everything works right. And then the optimization comes from Yana and Tony in the beginning. So when they're doing their optimization, they figure out what the stock lengths of the parts are going to be. And then we use those optimizations when we're doing our final release, so that we're using the same material that's been set up when they did that week of releases in the metal takeoff. So everything matches up.
That's correct. So let me show the CSULA documents. So after we do the optimizations, we can create a cut list. And it basically looks like this minus the highlights. So it shows the cut length, the stock length, quantity required, the stock length, the slots in the racks where they go, and the mark numbers. And you can see here the distribution. This is pallet number 17, week 1, day 5. And they have one for each part. Also in the release folder are the glass by pallet. And so this is important, that we have to make sure that the glass is correct, because you don't want to find out that the glass doesn't fit the frame when you're trying to assemble it. Because I heard their lead times on glass is pretty long, and they have to set that unit aside, and they can't package that entire pallet without that one unit missing. One of the outputs is also the pallet schedule. And if you don't do the step in the beginning where we upload the current information, this will be out of sync with what the field has and what the shop has. And there's additional documents here for the shop use by pallet, shop use by pallet by part. And before each release, there's this, in the takeoff program, there's this exclamation mark that tells us that there's these part numbers that are not attached. So this is an older database that I had a copy of from last month. So a lot of these have issues. The current database that Ron is using, Ron has on his local computer, and it doesn't have these errors. But normally, before we do the final release, we have to make sure none of these warnings exist. Otherwise, these reports will have problems. They'll have parts that are not assigned to a pallet, and they'll just be in a box somewhere, and they'll have to go hunt for them, which causes waste, because they'll have to look for it. Also in here are, I think this is for programming. Which parts go to which machine, I guess. Tony will talk more about that on his presentation. So our outputs are really based on a lot of the work that the previous groups did. all the way from jumpstart to drafting to prototype to metal takeoff, like all those groups, allowed us to make up these unit assembly drawings and these fab tickets. It's not always perfect at each stage, and so we have to, before we actually cut any material, we have to at this stage make sure that it's all correct. The frame size is correct, matches the shop drawings, and the glass fits in the frame. And so when it gets to the shop, they can have a continuous flow and be on time to send it out to the field. But if they run into any problems because we didn't check something, we didn't make sure it was right, the shop is gonna stop. They have to order material or whatever the case may be. So it's really important for us to make sure what we're doing here is like correct. It's really the last line of defense before they have to physically start, modifying the materials. After we release the parts to the shop, I think that's it for fabrication. But if the field has any issues, problems, we still have to answer, still provide that customer service until they're completely done in the field.
Okay, thank you, Chris. And then one of the other things we might touch on as well is kind of what our cycle time is. We have different sizes of projects that have different quantities of units that we have to build, but we try to stick to a pace that matches what the shop's doing. So do you want to speak on that just a little?
Yeah, there's some jobs that are simpler or a little easier. CSULA has a lot of strip window type of openings, and there are even the curtain wall is fairly simple. There are other projects that are more difficult. I think NNR was an example. I'm sure there are a lot of the bigger jobs, and so when we look at the unit tracker, we try to, we try to see where in the process where we would need more resources. So here on week 2, the unit will build 100 units, but in the office, we have to build 78 unique. So it's a very poor ratio of unique units to like total units. So trying to meet the time it takes the shop to build one unit, sometimes we would need more time than the shop. The shop can put a lot more people on to assemble one unit than in the office.
Yeah, and so our pace, the releases are by week. So you might have a job that has 6 weeks or 8 weeks, and we'll follow that same release pattern that the shop is using. So we'll try to do a release each Friday. And like Chris pointed out, we may have some weeks that have more units that need to be built, and we may need to apply additional resources in order to maintain that weekly pace. Usually by the time we release our fab tickets, we're 4 to 5 weeks before the shop starts. If we keep a normal week-to-week pace, then you will usually get some feedback from the shop by the time we're done releasing the units. So if they're coming across any challenges, then we can still react and make some adjustments if necessary. But next week, I'll be doing the unit checking process, which Chris didn't go into detail, but that's also kind of an intermittent step between what Chris was talking about for doing the creation of the fabs, getting them printed for checking, and then getting those out to the shop for release. So we'll be going over that in the step-by-step kind of process next week. Okay, very good. Any additional questions for Chris about the fabrication or how we're building the units out, the tickets?
I have a question.
Okay.
So Chris, let's say you're starting out on this job that you got up on the screen and you're gonna do like the first week, right? So you're, your first couple of days, you're gonna get set up, you're looking at those things you were gonna look at, the mock-up database, like all that stuff, right? But do you just start building the first unit? Like, do you just start on unit 1 right there on the first week and make unit 1 and then make unit 2, make 3? Or what approach
No,
do you take?
actually, I forgot to add a step after after procuring all those documents. I would sit down with the project coordinator and ask them, we would talk together. It's like, hey, now that we have the elevations and now that we have the key sheets, let's go look for units that might cause issues like transitions or slope raked bolted units, anything that might need more coordination than your typical intermediate units. We want to address, for me, I want to address all the difficult areas first in case we need input from the field or the shop or the engineer. And then we would go through the elevations and identify areas where, hey, let's work on this unit first, because the intermediate units have been probably been addressed during prototype stage. And so I have high confidence in the data and the fabrication drawings for those units. So I don't really have to check that. It's the non-typical areas where that might cause us problems. So also, we're sitting down with a PC and we'll look. It doesn't matter where in the week, in the release it is. It could be in week 2 or week 5. We'll just identify areas. It's like, hey, let's work on this one first and see what kind of issues, if any, we run into. That's in the very beginning, depending on how much time we have until week 1 actually starts in the office.
Okay. Yeah, it makes sense. So you tackle the hard stuff first because you might need more information and you can't have that happen during the week where you're trying to get it released, right?
Right. Because I mean, if we start to run out of time, we would ask for more resources, and it is usually easier to give those resources the easier units. You don't want to give them all the hard stuff at the end, because now everybody's gonna get stuck at each of those difficult units. That's due like 2 days, from the day you give it to them.
Yeah, sometimes I have something also that sometimes when I sit down with the harder one, we choose the unit for our main operator to do the harder one, transition units, but I categorize it as a priority 1 or priority 2. The priority 2 is the one that's easier one, which is the unique unit, and the one that need like a transition or need a compounded units. That should be done first by Chris, but actually he gonna do me a 1 unique unit while I'm checking down. She's working the harder one, and then once we get another resource or a help, then all the unit is already been back checked and done by that other operator that helped, and Chris will keep on doing the harder one.
Yeah, that makes sense. And then at the beginning, you were talking about the glass. Are you using Zach's comparing tool for the glass check with the takeoff browser?
I tried to. It's a little different. I asked him if he can, run exports out of that takeoff browser, but not currently. This one's a little different. It sorts it by the location ID
Mm-hmm.
of the glass database.
And we have that in the glass order form too, right?
Yes, the last tab on that glass order form has that same information.
Okay, cool. That's it for me. Who else has questions?
Right, good. Any additional questions for Chris?
Nope.
Good. Okay. Well, thank you very much, Chris. Did a great
you.
job.
Thanks,
Thanks a
Chris.
lot, Chris.
Thanks,
Thanks,
Chris.
Chris.
This was great.
And then I'll put the recording up for tomorrow.
Thanks, Chris.
Thanks, Chris.
Thank
Nice
you.
job.
Thanks, Chris.
Thanks, Chris.